essentially, what I will be focusing on this is this process of creating contextual change in an environment using essentially mixed media, in this case, meaning lighting, video projectors, screens, and sound. And you can use it for narrative-driven interventions like what you're seeing on the screen at the moment, or you can use it for workplace and wellness-related applications, which is what you see at the moment now, and lots of different types of permanent built environment installations. What I will be touching on quite a lot is sort of the principle why behind all this, which can be, for example, creating experiential environments, creating engagement, creating assistive environment where the light and media actually is sufficiently intelligent that it can help you in your everyday life. It can also nudge behaviors. It can be related to branding and the brand narratives and so on and so forth. What is kind of relevant here and what's maybe connecting this from kind of our perspective when we talk about intelligent environment is that they are data-driven. They are constantly shifting and adjusting themselves, and therefore they are sort of real-time environments. So even this installation of a big infrastructure that you see running on the screen right now, every night is different. Every light show is slightly different because it is all generated in real time using live data inputs like interaction from the participants, weather patterns, seasons, high days, and many more. And what that then does to the operator is that it adds value because the experience remains fresh and engaging and always shifting and changing thanks to the sort of built-in intelligence. So I think that would kind of hopefully frame this conversation. I'll give you another quick example because it'll help. So this is a little staircase. Every landing here has sensors. We can see in real time if somebody's going up, if somebody's going down. So they're not presence sensors. They're a little bit more intelligent than that. And with that, you can create a data set that essentially tells your client the usage of the staircase. This goes towards a so-called choice architecture. So in this case, there was a static light. When an upflow movement was added to the lighting, the usage went up by 6%. When interaction was added to the lighting, the usage of the staircase went up by 8%. So the end result was a 14% increase in the usage of a staircase in comparison to before. And this was then translated into benefits like calories burned, life extended, and electricity saved or energy saved. So I just wanted to basically quickly throw that in there. So when we again refer to intelligent environments, we kind of need to define the intelligence, and we need to define the purpose of it. And in a lot of the more successful cases, the purpose is actually sort of a behavioral goal. So in that staircase, the goal was that people would use the staircase more. People would burn a little bit more calories. It would become part of the wellness strategy for the building owner and a part of the whole narrative for the building. Now, if we then go into the technicalities a little bit, how do you go about trying to achieve something like this? So what I have here is a 3D preview segment of the Poet software. So the interface you are looking at now is our software called Poet Creator. It's a development that we've been working on for 6 to 7 years now. It's a very kind of commercial grade software package that allows you to do multiple outputs, multiple medias, content, and data integrations all in one package. So let's imagine that what we're looking at here is, for example, sort of idea that on the ceiling we would have diffused, maybe low resolution, pixelated light ceiling. On the front, we would have a sort of high definition LED screen. And then on the sides, we would have a video projection with, let's say, 3 video projectors, and they are blended. So the content appears continuous across the walls. So this is, of course, a super basic 3D model just to kind of help me to explain a little bit different elements and how you go about it. You can bring in your project model and work with much more complex models as well. So here now we're seeing sort of generative content being displayed in various different outputs. And that's kind of where this whole kind of magic begins to happen. So here we have a lot of different types of content engines. So if we look at another project example, for example, here, and we'll break it apart a little bit. So if you look at the ceiling, look at towards the end of the room, you see there's like a blue wave coming towards you, and that's basically the downlights changing color. Each downlight is treated as a pixel, if you like, through ArtNet control. There is video projectors hidden in the ceiling. They are creating that sort of a particle effect on the wall. And when the person walks past, there is an interactive effect achieved through a little hidden camera inside the ceiling. In fact, it's kind of hidden into a downlight. Now, how is this then achieved? So first of all, the particles. So the particle wave, this is the content that's been sent to that wall. And the way that sort of starts its life, so imagine that you're in the early stages of your project, you're looking for ideas, you would go to the system contents here, you would bring the particle engine, called particles here, and it starts its life looking something like this, so quite different. I click the emitter, I kind of start playing around with it. I don't need to be, a coder, and I don't need to be sort of motion graphics super specialist to be able to sort of look for and find different kind of effects here. So let's say I'll push the distortion up a bit, I'll make the strength down a bit, and now we already begin to see some kind of sort of wave-like motion happening there. The particles are a bit too big, so I'm going to make them a bit smaller. So you see every single parameter can be changed in real time. It's all happening in front of your eyes, and that 3D model that you see earlier, that would be on your second monitor when you're starting to work in your studio and trying out things. So now I have already that sort of thing. I want the background to be transparent so that I can layer this over some other content later on. So that's essentially how you go very quickly from a sort of like a standard content engine into something that's already looking that might work in the project. So for example, this. Now, the other element you saw there was this line moving across the downlights, and basically that's all it is. It's a moving line, and I have it here. So I go, okay, well, that's a bit too slow. I'll make it a little bit faster. I don't like the color. I'm going to make it a little bit deeper. So again, a real-time workflow. I can make it bigger. I can blur it more. So it's the same story. When you're actually on site, you'll be doing the same thing, looking, well, okay, now it's starting to look kind of okay. And then there was the interactive effect happening over the projection on the wall, and that's basically a CCTV camera. So in here, I have a USB camera, which is exactly the same from the purposes of Poet. I click the optical flow particles, the background is removed, and now I'm already kind of creating some kind of a lighting effect just by moving my hand. And then I start playing around with it. Maybe I'll add a bit of motion blur to it. Let's see, let's put a bit of noise in so they start moving. And now I'm already kind of like painting some kind of particle painting just by moving across the camera. So again, you see how quick and easy it is to sort of go from the starting point to something that looks already quite different relatively quickly. Let's give it some kind of tonality, and then there you go. Within a few seconds, you might have some kind of an interactive or responsive effect going on, and that's just with a normal camera. Another nice way of then doing content is using a 3D camera. So here's a 3D camera. I can see, for example, the depths of it. So this gives me kind of, apart from image, it also gives me data. So I can use the image as I was before, but I can also use the data for tracking purposes. So in here, we have a sort of swarm generator. It's another content engine. And I have a link here to the position X of the attractor. So this isn't the square there that you see. It's attracting those swarms towards them. And I can look from the camera now. So now I'm moving here, and I am the red square there, and I'm attracting that particular swarm towards me. If I make the strength negative, I start pushing the swarm away from me, right? So it's just to illustrate that very, very quickly with the depth camera, you can then begin to track people, begin to connect that tracking to different kinds of content engines in different ways. There's an example here. For example, there's a real project where something like this was done. So when a person walks past the screen, the swarm is attracted towards them, and turn around. The tonality changes depending on time of the day. The interactive effect depends if the person number 1 walks into the scene, and it's different if the person number 2 walks into the area, and so on and so forth. And basically, you begin to create a sort of an experiential feature that has a lot of longevity, because the content is not a loop. It's not a video loop. It's the real-time content. And you can link it to different data points to give it a little bit more variety over time. So that leads me nicely then to the sort of data integrations. So let's throw in, for example, one of the standard system contents, something like this. Again, I can sort of make this look very different very quickly just by pulling levers here. And so let's say we have that kind of some sort of cloudy setup going on here, something like that. And now I would like that to be non-repetitive content. So I'll take the ripple speed, I click the link, and that gives me basically available data inputs in my project. I go to live weather, I click the wind speed, I correlate it, let's say between 0 and 40. And now that particular parameter is now following live data harvesting. So every time a wind speed changes, that would change. I can do the same for the tonality of it. So I go to the color, click the link, and let's say I go to time, and I say I would like that color to change from, let's say, 8 o'clock in the morning and 12 o'clock in the morning, and to go from sort of a neutral white to sort of cooler tonality as the time passes. And there you go. So now your content is already data-driven and linked to sort of variables, in this case, time and weather. But there's a lot more. So you can go to the data input tab here on the left-hand side, and you start thinking, what is relevant in my project? So again, we're talking about intelligent environment, we're talking about contextual change. So what does that mean in your project? So the data kind of input become a very creative environment. So in here, I said that, okay, I'm working in an area that is very important to understand, for example, how people gather, how they're distributed around the space, how many people are there in a particular area, and so on and so forth. So maybe I'll use some 3D camera tracking here. I get not just the tracking of a particular person, but I also get things like total count of people passing the area. And any of these, I can just double click and create a data trigger from it. So let's just say we'll put more than 2 people in the room. And that's when I would like something to happen. I would like that to be a change agent. So people in a room, bigger or equal to. Now I have that data input. So you see there's a total flexibility on what sort of triggers you can create. Now I want to go a little bit deeper than that. I can use a different kind of sensor, basically a sensor with AI, built-in AI capabilities. I go to the people zone, and now I get data parameters like how many people there are, but also if they're men, women, children, are they wearing face masks, those sorts of things. So I can, for example, double-click the children, and I can create a trigger that says, kids coming in. So in the entrance area, I go bigger or equal 1 kid. I know kids are about to come in, do this. Change the videos, change the lighting, change the soundscape. Could be pretty interesting, for example, in a museum environment or any kind of exhibition space, to be able to do that. And so on and so forth. So there's a lot of kind of room for exploration here. You can create virtual lines when somebody crosses to a certain direction. They're going towards the bar, do this. And now they're leaving, they're going that way, do that. There's ambient sensing, so I can get CO2 levels in the boardroom. Are they an acceptable level, or are they getting a bit too thick, which would then impact on the cognitive performance of the people in the room. Same story with the temperature. Is it ideal temperature, or is it actually now getting so warm that anybody there would actually experience fatigue or possibly a reduced focus? So intelligent environment is self-adjusting. Intelligent environment is basically always optimal. That would be the goal, right? So in one hand, the environment shifts so that it accommodates you and your tasks or your goals. But on the other hand, the environment can shift so that it drives a behavior, like the staircase example. Now it gets even more exciting than that. So then you can bring in data harvesting. So let's say in this case, we have football here. So we are now tracking Real Madrid football team. So if at any given times they start playing, I would be getting in real time all these different data points. Are they winning? Did they score? Did somebody get a red card? And your entire sort of stadium facade can explode every time they score, or your sports bar can sort of anticipate changes or become red when the red card comes in, etc., or your home cinema when you're watching your favorite team. So you can basically inject a lot of drama and excitement just by having the right data inputs. And if you look on the left-hand side here, there's much more. So there is, for example, basketball, ice hockey, baseball, American football, stocks, all sorts of data harvesting opportunities there to create sort of intelligent, contextual, alive space. One good one is crowd noise. So that's simply a microphone. So you see that number there running. That's because I'm talking here. So you could hook that onto the crowd in an arena or a stadium. You could hook that into even into like an open plan office, where if a group of people arrive into the office environment, start talking too loudly, maybe the light shifts and changes to make them a little bit self-aware, and therefore changes their behavior. Or let's say you go to a spa environment, which really should be quite contemplative and quiet, but somebody comes in talking very loudly again, you could sort of like nudge very gently their behavior towards the sort of desired behavior. So that's what data inputs really mean. Okay, so now we have created some data inputs for your job. We played with some contents. We're starting to get something that looks maybe useful. Then you go into preset, and let's say we take an empty preset here. Now, how do I get this stuff onto the, in this case, we have the circular light ceiling, we have the projection walls, we have the LED screen. So they are here. So the LED screen is that thing on the top, the video walls are in the middle, the lighting layer is here at the bottom. I click the layers, it opens up my layers like in a Photoshop. I can put content over content. And then I just say, okay, well, let's put that wave thing, let's put that into the, onto the wall projection, for example. Let's take the camera upflow and put that onto the LED screen. And then what did we have? We had the line somewhere, line moving across. I'll drop that into my lighting layer. And now when I go to the 3D preview, I can see them here, right? So I can look around and then I go like, oh, well, actually, that's kind of looking okay there, that wave effect, but I would much prefer that it actually went across all the 3 walls and not be just in the middle. So I go back to my preset, check out my layers. Which one was it? Particle wave, that one. Double click it, it opens up here in the contents. I'm going to change the preview size to be kind of closer. So this is actually representing the whole width of those 3 walls. And I go, okay, well, how would I make it wider? So I go to emitter width, and I pull it all the way across like that. And then I go back to the 3D preview, and now that content is actually going across all the 3 walls, right? So that's really the beauty of the sort of the real-time workflow. You tweak, you see, okay, is that making sense? Oh, no, okay, change it quickly. You don't need to render anything and wait. So let's say you're now here, you're starting to sort of get something that begins to look kind of interesting and you would like to share that with your client. So on the top here, I press a button, capture image. That gives me an HD render of that particular view. I can send that to the client, say, hey, this is the direction. What do you think? I can also get a video here. So I just click record video. Now it starts recording and I can use the views as a sort of fly through. So very, very quickly, sort of rough and ready, you can begin to get sort of visual content that allows you to explain your kind of early ideas to the client. I press stop and that's it. I now have a video here that I can share. So that's essentially the workflow. So now we have created data input, created content. We have generated a bunch of presets. And now we would need to figure out how do we do the sort of contextual scheduling. So this is where it starts to get very interesting. So I have created here a bunch of empty states and I've given them sort of evocative names. So rainy morning, visitor arriving. So what does that mean? I go to my triggers, rainy. So I need a data input that tells me that, hey, it's raining right now. So real-time data coming in, raining. It's morning, so I need a time input. I'll drop that in. Visitor arriving, okay. So that would be, for example, through the 3D camera tracking, visitor in the reception, drop that in. So when all those conditions are met, I would very much like this to happen in the space. So when it's raining and morning and visitor in the reception, do this. Then let's say kids in the lobby. So I put back to my triggers. I look at the zone, for example. More than 5 kids in the lobby. Okay, cool. And maybe I'll just add a little, time-related thing there as well. Is that, okay, I would like this particular thing to happen in the afternoon. So kids in the lobby and it's an afternoon, then I would like this type of experience to happen in this space. Energy in the room dropping. So this would be for the meeting room. So I go to my ambient sensor and I go, okay, CO2 is starting to be kind of marginal. Maybe there's a temperature thing getting too warm. So if the CO2 is marginal and the temperature is too warm, then I would like to put something, powerful into this space, wake people up, or maybe I send a command to another system that maybe would open a window. So next to the presets, I have command tab here. I can do UDP commands, TCP/IP commands, OSC commands, those sort of protocols. So let's just say I send a command, so simultaneously that thing will happen. So now we're sort of managing multiple medias, data-driven, in a highly contextual way from the single platform. That's what's essentially happening here. And then final part of the puzzle is then the outputs. How does one actually set multiple outputs here? So I go to my output tab here on the left. Let's just put some kind of a little bit nicer preset running, for example, this. So now I'm in my outputs. So here on the left-hand side, I can add new outputs as much as I like. So this, for example, is now an HD output. I can change it to 4K or some awkward size or tiny little thing, whatever I want really. So in the software deployed side, we don't actually limit in any way the outputs. The limits will come later on from the hardware. So I have this bunch of outputs. So I've set that up as a screen. I've set this up as a blended video projection. So in here, you see the blending. So I can blend. I can go into any of the projectors, go to Keystone, and do things like typical sort of video tools. In the architectural world, it's always incredibly important that you be able to sort of adjust your projection to suit the architecture. So you can do that sort of stuff here. And then as a last bit, I have the lighting. So what I'm doing here is that I'm sending the lighting content as an MDI stream to a pixel mapper. So you could use a pixel mapper of your choice. In this case, we're using Elm. So now if I go to Elm, in here you see the blue wave that's actually coming in real time from Poet. And this is my LED strips here. You see all the ArtNet details. I can go into here and say, look, okay, the start address is 33. I can change that from ArtNet to streaming ACN or Kynet or, typical lighting protocols. And you can get to several thousands of universes with this arrangement all from the same computer. So basically, you're handling all these things from one point. And then when it comes to the kind of practicalities of it, you start your kind of work usually working with sort of content engines, the sort of preset content engines that Poet provides that gives you a very sort of fast way of getting stuff going on. So you see there's a lot of kind of abstract content engines that work particularly well in the context of low resolution lighting, etc. And you can always change all the parameters in every single one as much as you like. So you have those, but equally, if you need something a bit more specific than that, then you can also just bring in a TLSL shader. So this is also a real-time content. It's not a video. If I press the code here, you can see the code fully here. You can basically bring in any shader code and get that then connected to the Poet data parameters. Equally, you can, of course, just bring a video in. So all these examples I'm showing here, these are videos. So you can use it as a media server. Bringing in a video, you can bring in text, you can bring in scrolling text, all sorts of things like that. And there's a ton of effects you can then add to any content that you have going on. So let's say what we could put onto a text ripple. So now your text starts rippling away. So a lot of tools there. You can go pretty far with this. Equally, you can stream in content from other systems. So let's say you want Unreal-based real-time content. You can stream it in as an AV stream or take it in as an MDI input. So there's a lot of different things like that available to you. So flexibility, I think it's the name of the game here. And then when the way this goes together in a project is that you can use a computer of your own choice, or you can get a specialist media server from us. So they go from sort of a mini computer, which is good enough for a lot of the projects that you have seen. Let me actually show you one. This one would run on the mini. And the reason for it is that it's only lighting. So if you're only working with lighting, you can kind of achieve tremendous scale with quite a small amount of processing. So even something of this scale could run on a mini. But then when you start adding outputs, adding screens, adding things, then suddenly you need to go for a larger computer. So the next step up is something like this. And then you go from there into sort of a mega machine for bigger projects with a lot of different outputs. But equally, you can just get a security dongle and run Poet on the project with your own computer. And the way the licensing works is that for the designers, Poet is free. So everything I'm doing here right now, you could be doing in your studio for free. You go to our website, download the software, and that's it. When the project goes on site, that's where the license is then required. And in that case, the license is paid by the end client, typically speaking, the building operator. The licensing is structured around features. So you as a designer choose what features you actually need. So if you need a bit of AI tracking or interactive camera effects, the license grows and the cost goes up. So it goes from something like €2,500 a year up to, if you put all the data harvesting, all the sports, everything else for a mega stadium project, then you could probably hit something like 12,000 a year. But it entirely depends on the complexity of the project. So the idea really is that you can handle a quite small interactive environment or responsive environment, and then equally you can scale up to as large as you like. The other aspect of hardware is then the sensing. This one is the one that knows if you're a child or adult, etc. And what makes this interesting is that it's a network-based sensor where all the processing, all the AI is actually inside the sensor, which means into a project, you can put like 300 of these, connect them all together, and make your area be treated as one detection zone. And it gives you an enormous amount of data feedback, which is then also very useful potentially for your client. 3D camera we played around with. So this is a company called Stereolabs. It's a camera called Z2i that's been integrated here. CCTV cameras. With these, we get the image, but we can also get metadata. So any camera like this begins to then also act as a data harvester. Wall stations to allow you to do, or to allow your client to do sort of overrides if they need to, different sizes, and then a very, very, very secure remote access, which means that you can then use Poet as the platform to provide content updates, content management, and basically keep the project living and interesting as the years go by in a very kind of cost-effective way. So hopefully that gives you sort of the highlights of what we're talking about here and how we particularly approach something that could be considered an intelligent environment or indeed immersive environment. So the kind of guideline that we would recommend is to design from the human behavioral perspective. So in other words, what is the behavior you're trying to promote, which could be anything from engagement to wellness-related behaviors to sort of more experiential sort of immersive behaviors. Once you have an understanding of that, you can then begin to think, so what is the data that I need for this environment to actually act in a contextual way, so that it's not always the same, so it's not always dead. And from there, you basically go into the data harvesting aspect and sensor sort of choices. Do I actually need a camera, or do I just basically need a temperature sensor in the space and that's it? What do I need? Immersive intelligent environments are rarely very powerful unless you are able to instigate a change across all the different elements. So it's not really necessarily enough to change something on the screen, but equally it might not be enough to do it just on the lighting. You really kind of need to do it in both, and possibly even the soundscape, for it to really work. Humans are incredibly sensitive and receptive to sort of environmental shifts and changes. We're very aware of that. It's called pre-attentive processing that we do all the time. It's an interesting part of our sort of physiology because it requires very little energy from us, and that's basically how we intuitively know that something is happening or something is about to happen. It's coming from the pre-attentive processing. So these techniques of sort of taking control over all the elements within the environment tap into that. And then it's kind of up to the sort of creative development of the behavioral goals that makes it a success. So what we're doing here, what our job is that we are creating the platform that enables all that, and hopefully it enables it being done in an architectural environments in a lot more straightforward way than ever before. More cost-effective, simpler, and maybe most importantly, easy to change later. So these things can be quite hard to get right the first time. So it doesn't matter, even if you don't, a couple of weeks later, you can dial in remotely, do tweaks, and sell them as a service to your client until they're very, very happy and keep you going for many years in the same project, right?